Let us discuss a process of evaluating the integral of rational functions of sine and cosine. Examples of these integrals are the integral of dx all over 1 minus sine x plus cosine x. This kind of integral cannot be evaluated by any of the fundamental formulas that we have already discussed. Other integrals are integral of dx all over 5 plus cosine x. Still another is the integral of dx all over 3 minus 5 sine x. So these are the types of integrals that we are going to evaluate. Basically, the process involves some substitution. So let us start by considering a right triangle. So let us construct and consider the right triangle below. So let us construct a right triangle. And then we label this as follows: 2z, 1 minus c squared, and 1 plus c squared. And let the acute angle be equal to x. We first verify whether these are really the sides of a right triangle. And to do that, we will apply Pythagorean theorem. Okay? So we check if 1 plus c squared quantity squared is equal to the sum of the squares of the two other sides. So 2z squared plus 1 minus c squared squared. Okay, let us expand the right side. It becomes 4c squared plus 1 minus 2c squared plus c to the fourth equal to 1. 4c squared minus 2c squared is positive 2c squared plus c to the fourth. And 1 plus 2c squared plus c to the fourth is a perfect square trinomial equal to 1 plus c squared squared. And we have just proved that these are indeed the sides of a right triangle. Okay, so from this triangle, we can now define the trigonometric functions sine, cosine, and the other four of the angle x. So sine x is equal to the opposite side, 2z all over 1 plus c squared. Cosine x is equal to 1 minus c squared all over 1 plus c squared. So sine x will be replaced by the variable c. The exact expression for sine x will be 2z all over 1 plus c squared. For cosine x, it is 1 minus c squared over 1 plus c squared. So if there is a tangent function appearing in our integrand, then it's just the ratio of sine and cosine that will be 2z over 1 minus c squared. So from these two, or from that triangle, we can define all the 6 trigonometric functions. Now, how about the differential? So, if the original integral involves the variable x and the differential dx, we also have to change the differential dx into dz. So, to do that, let us define the tangent function. So, tangent x will be equal to sine over cosine. That will be 2z all over 1 minus c squared. Then let us take the differential of both sides. So that will be secant squared x dx equal to, we have here a quotient, so 1 minus c squared squared. Derivative of 2c is 2 times 1 minus c squared minus 2c. Derivative of 1 minus c squared is negative 2c everything times dc. And secant squared x, of course, is equivalent to 1 over 1 over cosine squared x. Na? So that will be dx equal to cosine squared x. We cross multiply. But cosine x is 1 minus c squared all over 1 plus c squared, quantity squared. Multiplied by, the numerator is 2 minus 2c squared plus 4c squared over 1 minus c squared, quantity squared, dz. So 1 minus c squared raised to the power of 2 over 1 minus c squared, quantity squared. We can cancel that. Alright, so our numerator will be 2 minus 2c squared plus 4c squared. So this is equivalent to 2 plus 2c squared, wherein we can factor the 2, so that will be 1 plus c squared dz over 1 plus c squared, quantity squared. And we can cancel 1 plus c squared. So therefore, our dx is equal to dz all over 1 plus c squared. Alright? So sine x becomes 2c over 1 plus c squared. Cosine x is 1 minus c squared over 1 plus c squared. And dx will become 2dc over 1 plus c squared. So these are the substitutions that we're going to apply. Then we integrate in terms of c. And we will come up with an answer which is a function of c. So it will require that we put back the original variable x. So to express c in terms of x, what we do is we integrate. No? Let us integrate this differential of dx. And integrating, so let us have a space here. Okay, we integrating both sides. We'll be getting x equal to 2 arctangent of z, or arctangent of c is equal to x over 2, and solving for c, we take the tangent function of both sides. We have tangent of x over 2. So this is the expression that will put back the variable x in the final answer. So these are the things that we should remember. Okay, so let us have some examples. We integrate dx all over 1 minus sine of x plus cosine of x. So our sine x will be equal to 2c over 1 plus c squared. Our cosine x will be 1 minus c squared over 1 plus c squared. And dx is 2dz all over 1 plus c squared. So dx is replaced by 2dz over 1 plus c squared all over 1 minus sine x, or 2z over 1 plus c squared, plus cosine x is 1 plus, or 1 minus c squared over 1 plus c squared. So what we have here is a complex fraction. We simplify. So 2dz all over 1 plus c squared all over, we combine these fractions in the denominator, 1 plus c squared will be the least common denominator. Then 1 becomes 1 plus c squared minus 2z plus 1 minus c squared. Okay, so you can see that 1c plus c squared can be cancelled. We can put the 2 before the integral sign. So 2 times the integral of dz all over 1 plus 1, that will be 2. C squared will cancel with negative c squared and minus 2c. And we can factor the 2 in the denominator. 1 minus c, where we can cancel the 2. So there's so many cancellations here. So what is left is dz over 1 minus c, and that is equal to the negative ln of the absolute value of 1 minus c plus the constant c. So let us put back the original variable x by replacing c by tangent of x over 2 plus c. If you don't want to see the negative sign, we can simplify this to ln of 1 over 1 minus tangent of x over 2. Okay? Plus c. So that is our final answer. Let us have another one. The integral of dx all over 5 plus 4 cosine of x. So the same substitution applies. Dx becomes 2dz over 1 plus c squared all over 5 plus 4. Cosine of x is 1 minus c squared over 1 plus c squared. That is 2dz over 1 plus c squared. And the denominator will combine into 5 times 1 plus c squared plus 4 times 1 minus c squared all over 1 plus c squared. We cancel 1 plus c squared. We have 2dz all over 5 plus 4, that would be 9. 5c squared minus 4c squared is c squared. And the denominator takes the form a squared plus u squared. We know that the integral of dz over 9 plus c squared is 1 over a, that is 1/3, because a squared is 9. So 1/3 arctangent of u over a, or z over 3 plus c. So that is equal to 2/3 arctangent of, our c is tangent of x over 2 all over 3 plus c. We take on another one. The integral of 3x all over 3 minus 5 sine of x. Dx is 2dz over 1 plus c squared 3 minus 5. And our sine is 2x all over, or rather 2z. That is 2c all over 1 plus c squared. So 2dz all over 1 plus c squared times 3 1 plus c squared minus 10c all over 1 plus c squared. So 1 plus c squared will cancel. 2dz over, what do we have here? 3 minus 10c plus 3c squared. There. And the denominator, sorry, three, okay, something wrong here. So dc all over 3 minus 10c plus 3c squared. And we can factor the denominator into 3. Okay, that will be 3c, 1 minus 3c, and 3 minus c. Let us check on that. 3 times 1 is 3, negative c and negative 3c is positive 3c squared, negative c and negative 9c is negative 10c. So what we have as our integrand is a rational function involving two linear factors. So we apply partial fractions. By partial fractions, 1 over 3 minus c times 1 minus 3c. These are two linear factors, so there are two partial fractions, a over 3 minus c and b over 1 minus 3c. So combining and then canceling both denominators, we have 1 a times 1 minus 3c plus b times 3 minus c. Okay, so when c is 3, this will eliminate the second term, no? Because when c is 3, this becomes 0. So 1 minus 3 times 3, that will be 1 minus 9. That is negative 8a. Okay, 1 minus 9 is negative 8. So our a here will be negative 1 over 8. Next, if c is 1/3, 1 minus 3c will become 0. So 1 equal to 3 minus 1/3 is 3 minus 1/3 is 8/3. So that is 8/3 b. So the value of b will be positive 3/8. Alright? There. So we continue. 2 integral of dx over 3 minus c, 1 minus 3c will become a negative 1/8 over 3 minus c dc plus b. Let's put a bracket there. So plus b 3 over 8 over 1 minus 3c dc. So 2 times The integral of dc over 3 minus c is negative ln. So negative 1 over 8 and then negative ln absolute value of 3 minus c. Okay, then plus 3 eighths plus 3 eighths ln of, okay, so we integrate dc over 1 minus 3c. So the derivative of 1 minus 3c is negative 3. That should be negative 1/3. ln of absolute value of 1 minus 3c plus c. So 2 and then positive 1/8 ln of 3 minus c minus the 3 will cancel here. So negative 1 over 8 ln of absolute value of 1 minus 3c plus c. Okay, we can factor 1/8, so 2 over 8 will be 1/4. ln of 3 minus c minus ln of 1 minus 3c. These two ln's can be combined as one. The difference of two ln's is actually the ln of their quotient. So 3 minus c over 1 minus 3c plus c. So we write our final answer in terms of x, 1/4. ln of the absolute value of 3 minus c is replaced by tangent x over 2 over 1 minus 3 tangent of x over 2 plus c. So one final example. We take the integral of dx over sine x plus tangent x. So dx is 2dc over 1 plus c squared over sine x is 2z over 1 plus c squared. And tangent x is sine over cosine. So 2c over 1 minus c squared. Okay? 2dc 1 plus c squared. We combine the denominators, the fractions in the denominators. So it will be 2c, for a while now. We can factor 2c also. Okay, and then we combine, that will be 1 minus c squared plus 1 plus c squared over the product, 1 plus c squared and 1 minus c squared. Okay, so what happened in the denominator is this: we factored 2c and then we combine 1 over 1 plus c squared and 1 over 1 minus c squared. So the least common denominator will be the product, 1 plus c squared and 1 minus c squared. Okay, so before we proceed, we cancel first 1 plus c squared. We can also cancel the 2. Alright, so we have now dz over z and then 1 minus c squared plus 1 plus c squared. C squared can also be cancelled. Negative c squared plus c squared. So what remains here is 1 plus 1 or 2. So the denominator is simply z. It is simply c. And then 1/2. Alright? 1 plus 1 is 2. C squared cancels with negative c squared. Okay, so what is the answer here? 1/2 dz over c is ln of the absolute value of c. Okay? Oh, by the way, wait. I think there's something wrong here. I missed out something. There is still a factor 1 minus c squared. Okay? There. So it's supposed to go up. It's supposed to go up. So it's not that simple after all. So it becomes 1 minus c squared over c dc. There. So 1/2 1 over z minus c squared over c is c quantity dz. Then we integrate. dz over c is ln absolute value of c minus z dz is c squared over 2 plus c. We combine this. ln of c minus c squared over 2 is 2 ln c minus c squared over 2. Okay, so that becomes 1/4. 2 ln of z minus c squared plus c. Or 1/4 ln of c squared minus c squared plus c. And ln and c becomes what? Tangent x over 2 squared. Okay? Your z is tangent x over 2 to the power of 2. Minus c, again, is tangent x over 2 squared. Plus c. So you work on the following numbers. So I evaluate the following. Dx over 1 plus secant x, 8 dx all over 3 cosine of 2x plus 1, dx all over sine of x minus cosine of x plus 2, dx all over sine of x minus tangent x, and dx all over 3 cosine of x minus 5.